Welcome back, students. In this video, we are going to look at naming alkynes. Whenever we name any compound, the first thing that we need to do is find the parent chain. The parent chain in this case has to contain the triple bond. What that means is both carbons in your triple bond need to be part of your longest continuous carbon chain. Let's go ahead and highlight our longest continuous carbon chain. So for this first one, I'm going to start over here. I'm making sure that my continuous chain includes the triple bond, and then I get to the end, and I could go up or I could go to the left, whichever one was making you happy that day, because it doesn't actually matter. For the next one, the way that it's drawn, that zigzag in the center, that would draw your eye into thinking that this might be the parent. But remember that we need to include the triple bond in our longest continuous carbon chain. So we're actually going to start up here and go this way so that we get our longest continuous carbon chain that contains both carbons of the triple bond. Now that we've talked about how to find the parent, let's bring in the rest of the rules. So when you find the parent, like we said, you have to include the triple bond, and you then number to give your longest continuous carbon chain. When we start actually assigning positions to these, which are called lockants or locations, what we need to do is give the alkyne priority over the substituents. What that means is when we start numbering, the alkyne gets preference. So it's more important to have the alkyne show up at a lower lockant than it is any substituents. That means that we're going to start numbering here with this being carbon number 1. This will be carbon 2. This will be 3, 4, 5, 6, and 7. If we would have numbered the other direction, then our alkyne would have gotten much larger lockants. We have several substituents here. Let's find them. Here is 1, and here are another 2. We have 2 chlorines and we have 1 ethyl. When we name these substituents, remember that chlorine turns into chloro. And now let's write the whole name. Our parent is going to be based off of heptane because we have 7 carbons. But for alkynes, what you do is you drop the A and E ending and put Y and E instead. So this is going to be heptyne. You need to be able to include where the location of the triple bond is. It's not always going to be at carbon 1, so you have to tell the reader the location of the triple bond. You also have to tell the reader where the substituents are. When we start putting this name together, remember that the substituents come first, and they're listed in alphabetical order. You do have 2 chlorines. The D and di for the 2 chlorines doesn't count as alphabetical order, so we're looking at the C for chloro. So we're going to start by calling this 6,6-dichloro. And then at the third position, there's an ethyl, so 3-ethyl. And then at the first position is your alkyne, so heptyne. Another way to write this would be to keep the majority of it the same. The 6,6-dichloro stays the same. The 3-ethyl would stay the same. But then if you wanted to break up the heptyne, you can put the lockant before the Y and E, and that works too. Both of those are acceptable. Remember some general nomenclature ideas: dashes between letters and numbers, commas between lockants. Because we have 2 chlorines, you have to include the fact that there are 2 with the prefix di. You also have to say where both of them are. So if you have a di in front of a substituent, you need 2 lockants. If you have a tri in front of a substituent, you need 3 lockants. So just make sure that you're not missing any lockants. Why don't you go ahead, take a moment, name these 2, and then come back and we can compare some answers. Welcome back. I have already numbered my compounds so that I'm showing the longest continuous carbon chain as well as the direction that we should be numbering. Remember, for that first one, I'm numbering from the left instead of the right, because if I number from the left, that gets my alkyne lower priority than my 2 methyls. When I assemble this name at the 5 position, I have 2 methyls, so I'm going to say 5,5-dimethyl. And then I'm going to tell the reader where the alkyne is. It starts at the 2nd position. So when you're putting in the locant for the alkyne, I know the alkyne has 2 numbers, right? It has a 2 and a 3. You put in the lower, right? So because the functional group contains 2 atoms, just pick the lower of this 2 locants. That's the one that you use. So you're going to call this a 2 because it's starting at the 2 position. So this is 2, and there are 6 carbons, so hex and then ine. If you like the other way where you break up the hexine, you can do that as well. You can say after the methyl, go ahead and put in hex. If you do that, make sure that there's no space between the L of methyl and the H of hex, right? That's all one word. And then you can put in your 2 with the YNE. The bottom one had a lot more carbons in it, so let's go ahead and look at that one now. It has both a methyl and an ethyl. Remember, when assembling the name, we list our substituents in alphabetical order. So the 5-ethyl is going to be listed first. Then comes the 7-methyl. And we end with a 1 non-ine. Right? The 1 locant is like math class. It distributes to the YNE. Again, if you prefer to split up the non-ine, you can do that. You can say 5-ethyl, 7-methyl, then no space between the L and the dash 1-ine. Beautiful. Let's wrap up. In this video, we looked at naming alkynes. We talked about how you needed that longest continuous carbon chain, and it has to include the alkyne. Your goal is to number to give the alkyne the lowest locant because it takes priority over the substituents. When you're assembling the entire name, make sure that you're changing the parent so that the suffix, the ending, is YNE. Then arrange the substituents in alphabetical order. Remember, mono, di, tri, tetra, those don't count for alphabetical order. You're looking at the first letter of the actual substituent. Thanks so much for watching. This is Katoni signing out.